Okay, our first question for in-class day 2 is we have a water balloon being thrown. We're going to give little Billy a hat. There's his water balloon. We are told that a water balloon is thrown vertically, so it's being thrown straight up with an initial velocity of 50 meters per second. So little Billy's throwing this water balloon up at 50 meters per second. We're going to call this initial throw times 0. And then we're saying assuming normal gravity, so we can, where do I want to put this? I'll put it over here. We're saying that our acceleration is our gravitational acceleration, which is negative 9.81 meters per second squared. And the reason I'm putting a negative is I'm going to go ahead and for this entire problem, if anything is moving upwards, it is positive. And since we're going up, down, we're going to just go ahead and call this the positive y direction. Now, a lot of the times we work with x, it's just a dimension change. Since it's vertical, we're going to go ahead and call it y. X's and y's are interchangeable so long as you're working specifically in whichever direction you define to be that x or y. So we are asked, assuming normal gravity, what is the maximum height the balloon will reach, and what is the velocity when it reaches the ground? So what we know is this balloon will continue to travel up until it reaches some point. And I'm going to draw this as a curve because otherwise I'm drawing on top of myself. It is going to reach some point up at the top here where the velocity is going to be equal to 0. It has stopped moving. It is starting to fall. This point we will call time 1. And then it's going to fall until we hit some point where it's gone back to where it started. We're assuming it threw from the ground. We were not told little Billy's height. In fact, little Billy was just me adding him to the drawing. And we're going to call this time 2. And what we know is that y, our position at time 0, is 0. It's on the ground. And our position at time 2 is also equal to 0 because we're back on the ground. We want to know when the water balloon hits the earth, how fast is it going? So before I put in my what to find, I'm going to go ahead and put in all of my known values. And of course, I am off the board. What do I know? Well, I know that my position at time 0 is 0. Again, this is just like if it was x0 position, except we're working vertically, so I'm calling it the y. My velocity at time 0 is positive 50 meters per second. That's all I know about time 0. I know that at time 1, I have hit my maximum height, so I am now going at 0 meters per second. I'm going to add units here. Perfect. And that's all I know about that top position. I know that my position at time 2 is going to be back to 0 meters. And I do know something else about all of these positions. Throughout the entire thing, my acceleration is that equal to gravity, which is negative 9.81 meters per second squared. That is everything I know. And now, what do I need to know? What do I want to find? what to find. Stolen again from a previous faculty who's now retired from here. So what do I want to find? I'm asked what is the maximum height the balloon will reach. That sure sounds like what is the height or what is the position at time 1. And then I'm asking what is the velocity of the balloon when it hits the ground. That sounds a whole lot like what is the velocity at time 2, because that is when it's hitting the ground. So those are the pieces that I am after. Well, our equations, we have x final, which we're now working in y, so we're going to call it y final, is equal to y initial plus velocity in the y times the time plus 1/2 my acceleration times the time. And we have my velocity final, and this is velocity initial, is going to be equal to my velocity initial plus my acceleration times my time. Notice that with this equation, since it's a v initial, we can actually work with the fact that the velocity is changing, unlike what we were able to do in the graphs for the last class. So velocity final is equal to velocity initial plus my acceleration times my time. And the last piece, which technically you could derive using the two of these, we'll show where it comes from later in the semester. But we have my velocity final squared is going to be equal to my velocity initial squared plus 2 times my acceleration times my change in position, which instead of being x, we're now going to switch to y. So y final minus y initial. This is what I'm working with. This is what I have to do it. So let's start with this top position, y at 1. So I can look at these equations and see that I have y at 0. So that would be my y initial. I'm after my y final. That's my y at 1. Oops. So what I'm looking for is in this equation. My v initial, I have my v initial, that's v0. I don't have a time. I have a 1/2, that's just a number. I have my acceleration, and I don't have my time. So this equation, I don't know either my y final or my time. So I can't solve that equation currently. The second equation, my v final, that's v1, so I have that. My v initial, that's v0, I have that. My acceleration, I have that. And that time, I can find it that way. However, I'm not actually looking for the time, I'm looking for y1. Now, if I were solving this, I rarely actually think to use this equation, because anything you can do with that equation, you can do with the pair of the equations above. So what I would likely do is use this guy. And then to solve for this time, and I can plug the time in up here, and then I only have one unknown. So this is 2 equations, 2 unknowns. It's a solvable problem. However, what we can do is we can say velocity final, I have that. Velocity initial, I have that. 2 is a constant. Acceleration, I have that. Y final, well, that's what I'm looking for. And y initial, I have that. So this guy will lead directly to that. Now, I'm going to do it my way first because I am stubborn. So I'm going to plug in this v final. So v final is v1 is going to be equal to v0 plus my acceleration times my time. If I go ahead and plug in for these numbers, my v1 is 0 meters per second. My V0 is 50 meters per second. My acceleration is negative 9.81 meters per second squared. And time is what I'm solving for in this equation. So what I'm going to do is subtract the 50 over, and I can say that time is equal to 50 meters per second divided by 9.81 meters per second squared. Meters cancel, one of the seconds cancels. I end up with units of seconds, and I get a number of 5.097 seconds. I can then plug that right back up into this top one, where I have my y final, which is what I'm solving for, is my y initial, which is position of 0 meters, plus my v initial, so that is 50 meters per second, times my time, which is 5.097 seconds. Again, I'm just going through this guy. It's a very small board. I don't have as much space as I do in class to write things out. I apologize. Plus 1/2 my acceleration, which is negative 9.81 meters per second squared, times my time squared. Ooh, I don't have it squared up there. Times my time squared, which is going to be 5.097 seconds squared. Apologize for missing that. If you were taking notes, please add that back in. So 50 times that. This is a calculator problem at this point. Everything's just plug and chug. This will give me an answer of 127.42 meters. So Y1 is Billy is launching this balloon an incredible 127.42 meters into the air. And that is done. That is one way to solve it. And that is how I like to do it, because it means I have to memorize one fewer equation. However, I also have this bottom way, which is going to go faster, because it's one equation and we only don't know one number in it. So what I can do is I can say my v final squared is going to be 0 meters per second squared, because at the top I'm not moving, is going to be equal to my initial velocity squared, so 50 meters per second squared. Might have to not write units on the board. Plus 2 times my acceleration, which is negative 9.81 meters per second squared, times, running out of room, my y final, which I want, times my y initial, minus my y initial, which is 0. Okay, that's 0, it goes away. That's 0, it goes away. I can say that 50 squared, I'm going to move it to the other side, so 50 squared, and this is negative because I switched sides with it, is going to be equal to 2 times negative 9.81 times y final. Technically, I should be keeping units in here, but this is meters squared per second squared because this entire thing is squared up here. And this is meters per second squared times this y final is going to have to be in meters. So all the units are going to work out so long as I get an answer in meters, which I'm hoping for an answer in meters. So that's no problem there. So what I will do is I will solve this for y final is going to be equal to, well, I'm actually going to go ahead and write it how I have in my notes. V1 squared minus V0 squared over 2a. That is if I just solve this for y final, ignoring the fact that y initial goes away. But if I plug all of this into my calculator, this is going to be 50 squared over 2 times, well, negative 50 squared over 2 times negative 9.81. And that final number is still 127.42 meters. Long-winded explanation of the fact that they're still the same. Okay. Now we just do exactly the same thing, but going down, because we need velocity 2. So, for velocity 2, I could go from 0 to 2, or I could go from 1 to 2. Either would work. However, it's going to be easier to go from 1 to 2 because I already have a 0 in there. So I'm going to go ahead and say that we're going from 1 to 2. Y final. Y2, I know that. Y initial, that's Y1. I just found that. So that's good. Velocity initial, I know that. That is 0. Time, I don't know that. 1/2 at squared, I can find time. So I know my acceleration. So the only unknown in this is time. Fortunately, time is not what I'm trying to solve for. My velocity final is what I'm trying to solve for. My velocity initial, I know is 0. Plus acceleration, I know, and time, I don't know. So there are 2 unknowns in this. So what I can do is I can solve this guy. I can solve this guy for time, this top one for time. And then I could plug that time in here in order to solve it. Or velocity final is what I'm after, is equal to velocity initial, that's 0, plus 2, I know that is 2, acceleration, I know, y final minus y initial, I know y final is 0, I know y initial is this piece I just solved for right there. So I can jump straight to it with this piece. So we could just do that if we wanted to. That's probably a little bit faster since I kind of showed that it works both ways initially. So let's go ahead and say that my velocity final, which is what I'm after, velocity final, or velocity 2 squared, is going to be equal to velocity initial squared, so that is 0 squared. That's nice. Plus 2 times my acceleration, negative 9.81 meters per second squared. Y final is 0. Y initial is 127.42, but it's a minus, so they've got a negative here, 127.42 meters. Units are looking good. I've got meters times meters per second squared. The square root of that is just going to be meters per second. So velocity 2 is just going to be equal to the square root of 2 times 9.81 times 127.42. If you plug that into a calculator, you're going to get 50 meters per second. However, if you recall, when you square something, 50 squared is, well, let's talk about a number I can actually square in my head. 5 squared, well, I guess I could do 50. Oh, this is square root of 50. Anyways, if I talk about 2 squared is going to be equal to 4. However, negative 2 squared is also going to be equal to 4. Negative 2 times negative 2 is also 4. So when we take the square root of something, we need to remember that this can be mathematically either positive or negative. So we need to either solve it in a way that we don't have to deal with that, or we have to know what this is going to be in order to work out. And in this case, if this is positive 50 meters per second, that means that our water balloon right before it hits the ground is moving upwards, which makes absolutely no sense. So we know that my velocity at time 2 is going to be negative 50 meters per second. And with that, I've found both of the things we're trying to find, and we're done. Again, reminder that you don't have to solve it this way. You could solve it this way up here, or you could even, and I do actually want to show this, so we're not actually done. I apologize. We can even ignore step 1, and we can go from, if we're going to take this guy still because it's easier, we can go from 0 to 2, because the acceleration is the same throughout that entire piece. As long as the acceleration doesn't change, you can take any 2 points. So from 0 to 2, we have velocity final, which we're solving for, is going to be velocity initial squared. Velocity initial, so velocity at 0 is 50 meters per second. Plus 2 times my acceleration, negative 9.81 meters per second squared. And then I have y final, so y2, which is 0, minus y initial, which is also 0. So 2 times negative 9.81 times 0 minus 0 is just 0. So velocity final squared is equal to, or just velocity final is equal to square root of 50 squared. Square root of 50 squared is either 50 or negative 50. And we go through that same logic, and we can say that it has to be negative because it is going down. Now, we've talked enough. So, take care.